everybody, this is your math video for multiplying and dividing radical expressions. This video specifically is going to talk about multiplication of radical expressions. So grab your note sheets and get ready to take a couple notes. So you can go ahead and fill in the date for today. These are pages 230 to 233 in your textbook. There are a couple things on the front of the note sheet. We're only going to do the first one about multiplying radical expressions. So to multiply radical expressions, it's very similar to multiplication. I'm going to throw an example up there for you to help you understand this. So if I have 2 square root of 5 times 3 square root of 6, I am multiplying two radical expressions, and I want to know what that equals. To do this, we multiply like things. I would do 2 times 3 because they're both outside of the radical expression. And then I would also take times 5, square root of 5 times square root of 6, and I would multiply these things together. So I have 6 square root of 30. Then I would consider, can I simplify square root of 30? Are there any perfect squares in there that I can pull out? 4 is not in there, 9 is not in there, 16 is not in there, and 25, which are all under 30. So no, that would actually be my final answer then, 6 square root of 30. Now if you can simplify any of this, you should. Okay, so we're going to go through a couple problems like this today, 5 of them actually, so get ready to write. Here we go. Here's my problem, 5 square root of 6 times the square root of 30 times 2 square root of 5. Notice up in the corner this time I threw a chart of perfect squares to help us, so we know what to divide by in order to see. So here we go. We are going to multiply like things. I'm going to multiply 5 and 2 together, and then I'm also going to multiply all my radicals together. So 5, let's write a couple extra things. 5 times 2, and then times square root of 6, times square root of 30, times square root of 5. Let's take those and do them. So 5 times 2 is 10, and when I take a calculator and I multiply all of those together, I actually get 900. So I have 10 square root of 900. Now I'm going to go over and look at my chart of perfect squares. I'm going to see if 900 falls in this chart, and in fact, it actually does. 900 is a perfect square. It's 30 squared. So just like we've been doing all along, I'm going to draw an arrow. I'm going to write that this is actually 30. I'm going to cross it out. That actually takes everything out of my radical. And if everything's out, I don't have a radical anymore. And I'm going to go ahead and multiply that 10 times 30. 10 times 30 is 300. So my final answer of this crazy problem to begin with simply comes all the way down just to the number 300. All right, problem number 2. 5 square root of 2 squared. So let's just reconsider what that means. It means 5 square root of 2 times 5 square root of 2. I need to multiply it times itself because it is a squared. All right, so I'm going to multiply like things. 5 times 5 is 25, and square root of 2 times square root of 2 is square root of 4. I am going to look at my chart of perfect squares, and I should already know, but 4 actually itself is also a perfect square, just like in our last problem. Draw my arrow down, it becomes a 2. I took everything out of the radical, so I'm not going to have a radical in my answer, and I'm going to multiply this. 25 times 2 is 50. So there's your final answer. Number 3. All right. Now, we have to, let me write this, and then we'll see if you remember what we have to do. So I'm squaring this whole thing. So I have 3x plus the square root of 11 times 3x times the square root of 11. That looks like 2 binomials. So I am going to either FOIL, oops, let's spell it right, first, outer, inner, last, or I am going to box method it. You have to choose one of the two. When I square a binomial, I must use the box method. You do not just make that 9x squared by multiplying 3x times itself, and you don't square the square root of 11 to make it square root of 121, you'd be missing the middle term. So we have to do the box method for this, and that's what I'm going to use because I think that's what you're most comfortable with. So let's use the box method to multiply these. So I'm going to draw my box. I'm going to go ahead and write 3x, square root of 11, 3x, square root of 11, and let's do some math. 3x times 3x is 9x squared. 3x times the square root of 11 is 3x square root of 11. Again, I have another 3x square root of 11, and I have the square root of 121. So let's write out everything that I just got, and remembering, again, like always, these two middle terms are going to combine with one another. So I have 9x squared plus this and this would be 6x square root of 11 plus the square root of 121. Last step, simplify this down any farther than that we can. If I look at 6x square root of 11, 11 doesn't have any perfect squares, but 121 does. So let's go up and look at our little chart up here, and I see that 121 actually is a perfect square. It is 11. So let's go ahead and simplify that. Let's drop down to our problem. I have 121 that actually becomes 11. There's nothing to multiply it by. Well, there is. There's a 1. So let's write what we have. I have 9x squared plus 6x square root of 11 plus 11. And then I need to think, can I combine any like terms in there? And there actually are not any like terms in there because that 11 doesn't share a variable. There's no more square roots of 11, so that is my final answer. All right, 2 to go. This one is already written like two binomials, and so you need to box method or FOIL this as well. So let's go ahead and box method. Draw our box. I have 5 square root of 2 and 3 square root of 5, 4 square root of 2. Let's start multiplying. First box, 5 times 3 is 15 square root of 5. Second box, 3 square root of 10. I'm combining things in like spots, okay? Third box, 20 square root of 2. And the last box would be 4 square root of 4. Now that's kind of a crazy thing that we got going on there. Let's double check. 5 square root of 5, that looks good. 3 square root of 10 looks good. 20 square root of 2 looks good. And 4 square root of 4 looks good. All right, so let's go ahead and see what we ended up with. Okay? 3 square root of 5, 4 square root of 2. All right, so I end up with, let's write them all out. 15 square root of 5 plus 3 square root of 10, 20 square root of 2, and 4 square root of 4. All right, let's consider each separately. Square root of 5, can't simplify that down. Square root of 10, cannot simplify that down. 20 square root of 2, cannot simplify that down. But the last one I can simplify down. So let's go ahead and do that. So 4 square root of 4, that's actually a 2. So that's gone. I go ahead and multiply that. So that's 8. So my final answer, I'm just going to erase here. This last term turns into an 8. There is your final answer. Now you might get some in your homework that combine, and maybe sometimes you won't. And nothing really combines in this one. All right, last problem. 2 square root of 13x squared. So remember again, you're doing 2 square root of 13x times 2 square root of 13x. This is the first time we're seeing a variable in here, and that is okay. All right, so let's combine like things. 2 times 2 is 4, and 13x times 13x is 169x squared. All right, so let's break down 169. Oh, before I move that, maybe I should go over here and circle it. 13 squared is 169. So 169 itself is a perfect square. This will become 13. And actually, remember, we can take out variables that are even, and this is going to become x. There's nothing left in my radical again. So I'm going to multiply 13 times 4 and bring the x out. 13 times 4 is 52. X. And that is actually my final answer because I had perfect squares inside my radicals. That is the end of multiplication. Good luck with this. Hopefully I get to see you soon. I'll talk to you later. Bye, guys.
Bye.